Hello everybody, this is Skill 26, which is the lesson about polynomial equations where we're going to do some factoring and maybe also use some quadratic equation. Alright, so to do this, we're just going to get right down to business. The way we're going to do this is first we're going to make sure our polynomial is in standard form. Standard form. Meaning that we have one side equal to 0. So that would be step 2. Well, standard form really means that we have exponent from high to low. Then we have one side equal to 0. We're going to factor as much as we can. So we're going to use all those wonderful factoring techniques that we've used throughout the semester. And then finally, anything that cannot be factored further is going to be a quadratic that you must solve. So in some cases, it can be solved just by using square roots. You may also need to use the quadratic formula. So we'll see some examples of each type. All right, on this first one, we've got x cubed plus 5x squared minus 2x minus 10. On this one, I see 4 terms. The exponents go from highest to lowest. So 3, 2, 1, and a constant. And it's set equal to 0, so we are good in that regard. So the first 2 steps are already taken care of. So now we're going to factor. Well, what is our technique for factoring when we have 4 terms? Well, hopefully you're thinking of grouping, which is exactly what we're going to do. We're going to factor by grouping. Within each group, we're going to look and see if there's a GCF. And in the first group, I can divide those by x squared. So x squared will come out. And when I divide those, I get x plus 5 left over. Now I have this minus sign here that is going to come down. And so that becomes part of the factors. And I can divide these by a 2. So negative 2 factors out, and we end up with x plus 5 when we divide. So now we factored by grouping, and so the x plus 5s are the same, so that's one of our factors. And we have x squared minus 2 as the other factor. Now looking at the x squared minus 2, I know that won't factor further, so I will leave that alone. X plus 5 doesn't factor anymore. So now we go to our final step, which is to solve. So we're going to take each of our factors. X plus 5 equals 0 when x is going to be negative 5. That's going to be one solution. X squared minus 2 equals 0. Now in this case, because I don't have an a, b, and c term, I don't need to use the quadratic formula. I can just do square roots. Okay, so x squared equals, whoops, jumping ahead of myself. X squared equals 2. We take the square root of both sides, and when we do that, just remember to do the positive and negative root, so plus or minus square root of 2. So our solutions are negative 5 and then plus or minus square root of 2. Okay? So this was a nice one, didn't need the quadratic formula for it. The next one, we probably will need the quadratic formula for it. I'm just guessing because it's provided for us, but let's see. For this one, what we're going to do is start by, so I see that everything is in standard form. So we have our exponent of 4, then 3, then 2, set equal to 0. So let's see, I can divide all those terms by a 2 and an x squared. So 2x squared is going to be a factor. And then that leaves me with x squared plus 3x minus 9. And so now I realize, okay, 2x squared, I could set that equal to 0. I divide by 2, and that gives me x squared equals 0. And I take the square root, and since the square root of 0 is still 0, I don't need to put a plus or minus on that one because it's 0. X squared plus 3x minus 9. If I tried factoring that, try to find two numbers that multiply to negative 9 and add to 3, I'd be on the struggle bus. So we cannot factor. Since it does not factor, we use the quadratic formula. That's why I have it written here, okay? Oops. So my x squared, I have an understood 1 in front of that, so a is 1. My b is 3, and my c was negative 9. So I'm going to write those in there to remind me what I plug in here. Because my a is 1, I'm going to plug in a 1 where I see the a's. Since my b is 3, I'm going to put 3's for my b's and negative 9 for my c. And I'm going to simplify this out. So we get negative 3 plus or minus. I'm going to go out to the side, work out the square root part. 3 squared is 9, and I have 2 minus signs. 9 times 4 is 36. When I add those, that's 45. Okay. And now when I look at that, square root of 45, let's go out to the side, see if we can get a perfect square out of that. And it looks like I can get a pair of 3's out of that. So I'm going to write this as negative 3 plus or minus. Instead of square root of 45, I'm going to use 3 radical 5 all over 2. Okay, and those are going to be my other solutions. So we got x equals 0, and then we got x equals this piece right here. Okay? All right, going on to another example. For this next example, I need to first make one side be 0, so I have to subtract 45y on both sides, and there's no like term to subtract that from on the left side, so I'll just put it at the end. I get 3y cubed plus 15y squared minus 45y equals 0. Now I look for that GCF. So I can divide all three of these terms by 3y. So 3y is a factor, and we end up with y squared plus 5y minus 15. And that's going to be what we look at to solve. So 3y, I can set that equal to 0, divide both sides by 3, and y is 0, so that's going to be one of our solutions. Y squared plus 15y plus 5y minus 15. Two numbers that multiply to 15 and add to 5, well, they don't exist. So this one does not factor. So this right here does not factor, so we're going to go to the quadratic formula. Now notice we have y's here. These say x's. We can easily change those to y's. So I have 1y squared plus 5y plus negative 15. Okay? All right, so my a's are 1's, my b's are 5's, and my c is negative 15. So I plug those in. I'm going to work out this part right here. That's going to give me 25 plus, because I have two negatives here, 60, which makes 85. So when I solve this out, I have negative 5 plus or minus square root of 85 all over 2 times 1, which is 2. Looking at this, the 85, let's see, 85, I could divide that by 5. So 85 divided by 5, I get 17. But 17 is a prime number. We're not going to get a perfect pair of a number out, so no worries about that. We can just leave our answer as this. So y equals 0 was one solution, and then y equals to negative 5 plus or minus square root of 85 over 2 is the other one. Well, the other two, should I say. All right, last one. For this one, we're going to have to remember some factoring techniques aside from the ACB tree, which is what we've been doing. We have x to the 6th minus 64. Well, since I can square root both of those, I'm going to factor using my difference of squares pattern. The square root of x to the 6th is x to the 3rd, so I'll write x to the 3rd as the first factor. Square root of 64 is 8, so I'm going to use 8 as my second factor, and I put a plus in one and a minus in the other. Okay? Now, we should hopefully remember that when we have x cubed and then 8 is also a number that can be cubed, that means that we can factor this using the sum and difference of cubes. Okay, so I'm going to do that out to the sides here. X cubed, the cube root of that is x. The cube root of 8 is 2, because 2 times 2 times 2 makes 8. We square this and put it here. We square this and put it at the end. And in the middle, we're going to multiply x times 2, so we get 2x. The signs, I've got a plus here, so this sign will be the opposite, and this last sign is always plus. Okay? Now I'm going to go to the other one here, x cubed minus 8, so we know x cubed, the cube root is x. Cube root of 8 is 2. Have a minus sign. X squared goes here. 2 squared, which is 4, goes here. 2x in the middle. If this is minus, then this is plus, and this one will always be plus. Okay, so I've done all the factoring now. So here's what I'm going to do. This is a quadratic that must be solved. And this one is a quadratic that also must be solved. Okay? From our original answers, x plus 2 equals 0 when x is negative 2. That's one answer. And x minus 2 equals 0 when x is 2. So we've got two of our answers. Each one of these other quadratics I need to solve out using the quadratic formula. So let's see, we have 1x squared plus 2x plus 4. I'm going to plug in 1s for A's, 2's for B's, and 4 for C. Let's see, working out the square root part here, I'm going to get 2 squared is 4. I have 1 minus sign. 4 times 4 is 16, so it's going to give me negative 12. And hopefully we know that when we have a negative under the square root, that's going to be an I thing. So 12, I'm going to break down into 4 and 3. We get a pair of 2's from that. So we're going to have negative 2 plus or minus. That pair of 2's will come out, but so will an I, with 3 left over, all over 2. And because we know that this 2, and this 2 are all multiples of 2, we end up with negative 1 plus or minus I radical 3. Okay? So there's two more answers. Now I'm going to go and do this last one. So we took this, we're going to put them in here. This is what we've got. We're going to plug in negative 2 for our B's. Plug in 1 for the A's and 4 for the C. That gives me negative 2 plus or minus square root. When I do this part under the radical, I end up with 4 minus 16, which is negative 12. And we did this one already, so I don't have to redo all the work for that. We know that square root of negative 12 is going to be 2I radical 3. And we also know that all these will, I don't know why I can't write all of a sudden. Huh. Okay, I'll just use my mouse here to finish this off. All those divide by 2, so I end up with negative 1 plus or minus. Wait a minute, I realize I made a mistake here. It shouldn't be -1. We had -2 over here, so that makes this +2. There we go. I was like, something seems off. There we go. Those are our other answers. Everything I put in a box is going to be our final answers. Okay? All right, so we'll do some more practice on this in class, and I'll see you then.